All right. Well, it looks like it has kind of died off with people getting on here. So we're going to go ahead and get started today. Thank you for joining. This is the last of our Water Quality Wednesday series for 2026. Today's topic is kind of on acid mine drainage, some of the remediation techniques, and possibly East Palestine water quality environmental update. Um, from a variety of speakers today. The lineup is looking really, really good. So hopefully you all enjoy this webinar. Just to mark your calendars if you're interested, we do have that Certified Livestock Manager webinar series. This does go on throughout the whole year. They are now only 1 hour long. So our next one is on April 6th, and that is on emerging technologies and NIR sensors with Dr. John Fulton. We have a couple different ones coming up as well. We have one on June 1st and August 3rd. These all start at 10 o'clock in the morning, and the registration link is there on the left-hand side. And I will try to throw that into the chat here in just a little bit. And in case you didn't know, today's webinar is brought to you by the OSU Extension Water Quality Team. And I believe actually the whole team is on this webinar today. So up in covering Williams, Fulton, and Lucas counties, we have Heather Torlina up in the yellow. Paulding, Defiance, and Van Wert, we have Rachel Henry, and she is covering the orange ones. Myself, Jocelyn Rubel, I cover Auglaize, Allen, and Mercer counties. I am in the purple. Putnam, Hancock, and Hardin is kind of vacant at the moment. Henry Wood and Ottawa is Amber Emmons, and she is in that bluish green color. And then Crawford, Wyandotte, Seneca, Sandusky, and Erie is also vacant at the moment. If you aren't familiar with us, please feel free to check out our website, waterqualityextension.osu.edu. That link is right there for you guys to check out and see what we do. So we have some great speakers today. We have Amy Mackey with The Ohio University. We have Dr. Yang with the University of Utah. And we have Dr. Hattey with the Ohio State University. And I believe we are just going to go in that speaker order. So I will start off with Amy here. Amy coordinates restoration work in the Racoon Creek watershed and assists with other environmental projects as needed. She has experience with watershed project planning and maintenance, chemical, physical, and biological monitoring, and planning and facilitating outreach and education events. Dr. Yang is an assistant professor at the University of Utah, specializing in extractive metallurgy and resource recovery. Her research focuses on developing advanced technologies for sustainable critical materials production through innovative extraction, separation, and recycling processes. Dr. Hattey is a professor at The Ohio State University within the School of Environmental and Natural Resources, focusing on soil science. His leadership and expertise on the East Palestine project has been tremendous in helping with remediation efforts. So with that, I am going to stop sharing my screen. And Amy, we will start with you.
All
Yep.
right. Well, thanks a lot for having me. And if by chance you've already heard me present this, I apologize, and you can just sort of not pay attention to this part. I've presented to a lot of folks in the past year or so. Anyways, thanks again for having me. My name is Amy Mackey. I am a project manager and Raccoon Creek Watershed Coordinator here at the Ohio University Voinovich School in Athens. Today I want to cover, this will be fairly brief to try and fit it all into half an hour or so, but I want to touch on the restoration and recovery of the Raccoon Creek watershed. Okay, there we go. All right, so where is Raccoon Creek? If you're not familiar, we're down here in southeast Ohio. The watershed drains parts of Hawking, Vinton, Athens, Meigs, Jackson, and Gallia County. About 684 square miles. We are a direct trib to the Ohio River. The main stem of Raccoon Creek is 112 miles long. We start just below the Hawking Hills and drain into the Ohio River around Gallipolis. In the 1980s, concerned citizens down in Gallia County, where Raccoon Creek drains into the Ohio River, realized that there were some issues with Raccoon Creek. There just wasn't a lot of biodiversity there. There was a lot of erosion. There was a lot of sedimentation. They formed the Raccoon Creek Improvement Committee. This was concerned citizens in Gallia County who wanted to help make the watershed a better place. Eventually, they gained support from community members of all 6 counties in the watershed, At that time, Raccoon Creek was considered too far gone and unrecoverable. It was not even on the radar of agency folks as a restoration target. Finally, in the 1990s, the citizen groups got agency attention and projects began in the watershed in the late 1990s. In 2007, the Raccoon Creek Partnership 501c3 watershed group was formed. The partnership is governed by a seven-member board of directors. We host two AmeriCorps members each year, and we partner with agencies, landowners, and community members for projects and watershed outreach. So, what are the problems in the Raccoon Creek watershed, and how do we fix it? Number one issue in Raccoon Creek, historic pre-law coal mining. And everything I'm talking about is mostly focused on Raccoon Creek, but definitely a widespread regional issue, just most of my experiences in Raccoon Creek. So historic pre-law coal mining, number one issue in Raccoon Creek. Other impairments as a result, or other impairments besides the coal mining, low-head dams, invasive species, loss of riparian and streamside buffer, and failing and non-existent home sewage treatment systems. The pre-law coal mining impacts about 50,000 acres of mapped pre-law mines in the Raccoon Creek watershed. And these are only the larger mapped mines. These were not all the small home mines that people used, to heat their own homes. This 50,000 acres of mapped mines impacted approximately 190 stream miles in the Raccoon Creek watershed. Primary impact from the pre-law coal mining was acid mine drainage. The acid mine drainage increases acidity and metal concentrations. The sort of elementary version of mine drainage, iron pyrite in our coal in this region, combined with water, combined with oxygen, results in, among other things, sulfuric acid. So when we're talking about acid mine drainage as a result of coal mining in Southeast Ohio, typically referring to that sulfuric acid. Other pre-law mining impacts, sedimentation, erosion, habitat degradation, lack of species diversity, and increase in invasive species. As you all know, the optimal range there for life is in that sort of 6 to 8 range. Anything lower, acidic, anything higher, alkaline. The acid mine drainage that we're dealing with is typically in that 2 to 4 range. So things like lemon juice, Coca-Cola, and vinegar. I'm trying to. There you go. Sorry, I had people covering my map there. Our acid mine drainage reclamation and treatment project started in Raccoon Creek in around 1998. That map on the right there, it does not include all of our projects, but those are sort of the clustered groups of projects in the watershed. You can see a large group of projects up in the headwaters in the Hocking, Vinton County area, and then another large cluster of projects in Jackson County, which is actually in Little Raccoon Creek. Those are the two areas most impacted by mine drainage and also the two areas where most of our projects are focused. Over $16 million in AML funds, 319 grants, and Office of Surface Mining funds have supported 22 reclamation, treatment, and major maintenance projects in the Raccoon Creek watershed. These projects that I'm talking about can only be completed on abandoned mine lands. Nothing that we do is on regulated current mining sites. These are all abandoned pre-law mine sites. The Raccoon Creek main stem and Little Raccoon Creek have always been the goals for recovery. There had to be a focus. Every little hollow in the headwaters in Little Raccoon Creek have been impacted, but there had to be a focus on addressing those issues that would have the greatest improvement on Raccoon Creek and Little Raccoon Creek. Some of our funding sources, the majority of our funds come from the AML funds administered by ODNR Division of Mineral Resources. These are federal grant funds allocated to ODNR Mine Lands Program as part of the Infrastructure Investment and Jobs Act that spanned from 22 to 36. ODNR is awarded $46.4 million grant to fund abandoned mine land reclamation and acid mine drainage treatment throughout the state's coal mining region. So this is the primary funding source for our reclamation and treatment projects. Almost $13.5 million in Raccoon Creek projects have been funded through these AML funds. These funds also support staffing for monitoring, maintenance, etc. This is our primary funding source for restoration work in Raccoon Creek. Other funding sources 319 non-point source grants administered by the Ohio EPA. This is supplemental funding toward those AML funds. These fund other watershed restoration projects as well as AMD projects, including Lowhead Dam removal, riparian restoration, any projects that are non-point source related. About $2 million have been spent in Raccoon Creek through these 319 grants. Another funding source, the Office of Surface Mining Watershed Cooperative Agreement Program grants, about $1.5 million in Raccoon Creek has been funded through OSM. Three primary mechanisms for treating acid mine drainage and abandoned mine lands: active treatment, passive treatment, and reclamation or source control. An active treatment project is a project like a doser. We have one doser in Raccoon Creek that is actively adding an alkaline material, in our case it's calcium oxide, to an acidic mine source to neutralize the pH. These active treatment projects have a low initial cost, pretty high maintenance cost. They do require continuous maintenance. Passive treatments, water is flowing through some sort of system, picking up alkalinity and or precipitating out metals. Moderately high initial cost, moderate maintenance costs. Examples of passive treatments would be steel slag leach beds, open limestone channels, successive alkaline producing systems, wetlands. Both active and passive treatment, these projects are installed at sites where there is an acid mine drainage issue that we cannot stop or reduce, and we have to treat that source. Reclamation or source control, often these projects are completed on surface mined areas where we can actually eliminate or reduce the formation of acid mine drainage. So we are not just treating it, but we are stopping or reducing it from forming. High initial costs because we're moving a lot of dirt, but very low to no maintenance costs. This is a picture of our active treatment in Raccoon Creek. This is the Carbondale doser. This system is run by the water coming from an underground mine. That water turns a water wheel. There's a gearbox, turns a chain, turns an auger, and dispenses calcium oxide into the stream. Very effective project, pretty maintenance intensive, but very effective at reducing the impacts of acid mine drainage. Some of these passive treatment systems, we have several steel slag leach beds in the watershed. Steel slag is an alkaline byproduct of the steel industry. There's a lot of lime incorporated into this material. Water flows vertically down through that steel slag and sort of supercharges clean water with alkalinity. And then we discharge that water into our acid mine drainage sources, helping to buffer the acid mine drainage. Slag does need replaced. Valves need cleaned. There are maintenance things, but not constant maintenance like at the dosers. Wetlands, everybody knows the benefits of wetlands, very similar in acid mine drainage world. Water flows into these wetlands, slows down, precipitates out a lot of metals, minimal or no maintenance once they are established. Usually we are enhancing existing low quality wetlands to increase their storage potential to help slow down some of these materials from going down the watershed. Reclamation and source control. The top photos here are some pre-construction photos of a site in Hawking County. This was a highly acidic, a lot of aluminum, ridgetop surface mining. These pits had no drainage. They were basically a big coffee maker. Water came in, percolated through all that material, and created extremely acidic, metal-laden waters. That site and many others reclaimed to restore positive drainage so the water can flow off of that site as fresh water and not generate acid mine drainage. Lowhead dams, another issue in the Raccoon Creek watershed. I won't focus on this today. This will be more acid mine drainage focused, but these are the other impairments in the Raccoon Creek watershed. These lowhead dams are non-regulated, typically smaller dams, originally installed to operate grist mills, water treatment, municipal water sources, road crossings. These dams do inhibit fish passage. They're a severe human safety risk, often referred to as drowning machines. Disrupt stream channel morphology, over-widening the stream upstream, downstream, precipitating out a lot of material. There's 4 lowhead dams still in the Raccoon Creek watershed. The very mouth of Raccoon, near the Ohio River, there's the Northup Dam. That one's really not much of a water quality issue anymore or habitat issue. It's disintegrating, minimal or no impact. It's actually sort of a pretty good riffly area there now. Cora Mill was a dam built to run a grist mill. The man-made portion of that is gone, and the existing part that is still there is actually a natural rock shelf. so that will never be addressed. Still is acting as a low head dam at low flow, but it's a natural function. The dam in Vinton, this one is our priority for removal. I'll show a couple more pictures of this one. And it is also, as I'll talk about later, the boundary of our exceptional warm water habitat reach. It's in Gallia County. There is another lowhead dam in Wellston that we would love to remove, but it's actually backing up water for their municipal water supply. So as of right now, that one can't be removed. Hopefully in the future, that one might be able to be removed. One dam that we have removed, funded by an EPA 319 grant, was the Sandy Run Lowhead Dam in Vinton County. Sandy Run forms Lake Hope. It's a small stream. This dam was chosen as a project because it was on public land, and Zaleski State Forest helped with the project. They did the removal. Even this very small dam, it was only about 40 feet long and 3 to 4 feet high, but it was still serving as a barrier to fish passage. There were 12 species of fish found downstream of the dam and only 4 species upstream. So this dam was preventing those species from moving any farther upstream. This dam was partially removed about half of the dam. Within the first 2 rains after the dam removal, you really could not tell that there was ever a dam there. It was amazing how fast that small stream recovered once the water was free flowing. This large lowhead dam in Vinton, this one is one that we would love to see out of here. It's located in Gallia County, about 40 miles upstream of the mouth of Racoon Creek. This one's a significant barrier to fish passage, and it's also a fairly significant human safety risk at high flow. Right now, this dam is on private property, and the landowner is not interested in doing a project right now. But this is sort of big recent news. In January of this year, part of this dam actually blew out, and it has been, with these high flows, these chunks of concrete down here have been moving. So even though the landowner was not really wanting a project done here, nature kind of had a different idea. So that dam seems to be on its way out. Very curious to see how the fish populations recover as that sediment moves downstream and how as fish are able to move upstream. Invasive species, another issue in the Raccoon Creek watershed. Asian carp are a filter feeder. They were intentionally brought to the U.S. at one point, and then have really taken off, as most of you know. Prolific spawners, 50,000 to 5 million eggs per female in ideal conditions. These fish are a very large filter feeder, directly competing with our native fish. Documented in Raccoon Creek in 2016, we were able to assist U.S. Fish and Wildlife and several other agencies in a tagging and removal effort in Raccoon Creek and the Ohio River near the mouth of Raccoon Creek. This work is ongoing to detect movement, figure out how these fish are using our locks and dams and how they're trying to move upstream, and hopefully keep them from moving upstream too much farther. Monitoring and maintenance. So we have all of these projects in the watershed. Once a project is in, that doesn't mean it's just done and Raccoon Creek is magically better. These projects require continuous maintenance and monitoring. Long-term monitoring observes trends and changes over time. Some of these sites have been sampled continuously since the 70s. Project-specific monitoring is more to determine how successful or unsuccessful a project might be, when maintenance needs done, if steel slag needs replaced, to know how often we need to replace those. We're constantly doing monitoring. Chemical sampling is conducted as needed throughout the year. Fish and macroinvertebrates are sampled approximately every 5 years. We'll actually be doing biological monitoring this summer in Raccoon Creek, so this is a big year for us. Projects require continued maintenance. We're out at the doser, that active treatment project, at least once a week. There's a lot of moving parts there, really poor water quality, so lots of work needs done there to keep these projects moving. Passive treatments, we're flushing valves, replacing slag, cleaning pipes, just maintaining these projects so that they function effectively and efficiently. Some monitoring photos here. We do long line electrofishing. We also have a boat electrofishing unit, macroinvertebrate sampling, chemical sampling. These things are all to determine how effective our treatments are and where we might need to focus further efforts. Project maintenance, adjusting water levels, cleaning culverts, cleaning out valves, replacing parts of the doser, cleaning the doser channel out, ongoing things. So, recovery and success. Here's the exciting part. I am thrilled. I've been working in Raccoon Creek since 2007. So, it's very exciting to be working in a watershed that's improving. So, being able to share good news. Is all of this stuff working? 4 decades of work, all this money, all these projects, all of these partners doing work in Raccoon Creek. Yes, luckily, this has been a successful story, or I probably wouldn't be here talking to you today. One of my favorite projects or one of my favorite parts of this job ever since I've been here in the almost 20 years. We were monitoring a site in Little Raccoon Creek, a site that was historically dead. It was on private property, so we had asked the landowner permission to drive through his field. He's like, "Yeah, you're welcome to go down there, but you know there's no fish in Raccoon Creek." We're like, "Okay." So we go down and we do our monitoring, and we had about 20 some pans of different species of fish lined up on the front of the boat. And he came down at the end of the day just to see how we did. And he was so amazed, so excited that there's actually fish in Raccoon Creek. So those are the moments that we really enjoy. In 2022, Ohio EPA officially approved upgraded aquatic life uses for most of Raccoon Creek. Over 100 stream miles of Raccoon Creek and Little Raccoon Creek are now meeting or exceeding criteria for warm water habitat designation. The most downstream 32 miles, so that's from that dam in Vinton down to the Ohio River backwaters, are now meeting exceptional warm water. So that's the best of the best from a stream that was once written off as unrecoverable, too far gone to ever improve. So that's really super exciting for us. We're seeing biological recovery downstream of projects, more fish, greater diversity, lower percent of tolerant species, higher percentages of sensitive species. Over 90 species of fish have been recorded in the entire watershed at this point. In 1981, there were only 21 species of fish in Raccoon Creek. In 1984, the mouth of Little Raccoon Creek had only one species of fish, which was the long-eared sunfish. Fast forward to now, the main stem is seeing almost 80 species of fish, and Little Raccoon Creek 34 species. We're seeing sand darters and paddlefish in Raccoon Creek, both species that are relatively uncommon and need healthy, clean water to survive. Plus, when your water is healthy, people actually want to come to the watershed to recreate. So, increased recreational opportunities. We do have a thriving livery on Raccoon Creek now. If you're familiar with this area, there's several liveries on the Hawking River that are very popular. A lot of people go to those ones. Big kind of party destination. Raccoon Creek's a little different story. It's a very rural, lots of trees, lots of portages. So this is for the folks that really want a unique Southeast Ohio experience there, but it's a beautiful section of stream and highly recommend supporting Raccoon Creek Outfitters at their canoe livery. Our big news, our big recent news is Raccoon Creek recently was designated the first scenic river in Southeast Ohio. In 2018, I originally approached some DNAP personnel because I saw this map that's on here that shows all of these fantastic scenic rivers. I'm originally from Northeast Ohio, grew up right there on Conneaut Creek. So exciting to see all those scenic rivers in the state, but there was this massive void in Southeast Ohio. Most of the scenic river maps actually had their legend smack dab in the middle of Southeast Ohio because there were no scenic rivers there. So I started this conversation with the DNAP personnel. I was told, water quality in Southeast Ohio just isn't very good, not a lot of interest. And so I started educating them on some of the work that had been done, getting support from some other partners. And very long story short, Raccoon Creek was officially designated the first state scenic river in Southeast Ohio on November 12th, 2024. It was a long process, but the restoration of Raccoon Creek from a dead, impaired, too far gone to recover watershed to a watershed meeting and exceeding water quality targets was made the watershed a really ideal candidate for designation. We worked closely with DNAP personnel to gather the data they needed, completed a designation study. We met with county engineers, commissioners, trustees, soil and water districts, park districts, conservation clubs, basically anyone who would talk to us. We met with them to explain what the designation would mean, how it could potentially impact them. And in the fall of 2024, Director Mertz made the choice to designate, and we held that ceremony at Lake Hope. That was the official ceremony. And then on June 14th, 2025, we had a large public celebration at Lake Hope and we had over 100 people in attendance. That was really, really an exciting event for Raccoon Creek. And now we are officially on the map. And since then, we've added another stream in Southeast Ohio. Scioto Brush Creek has also been added. So that was a big success story for Raccoon Creek and all of the partners who have made the watershed restoration possible. Huge thanks to all of those partners who help support, manage, fund, monitor, outreach, all of this work that goes on in Raccoon Creek. We couldn't do any of this without this whole group of folks. ODNR, the Voinovich School here, EPA, Office of Surface Mining, Wayne National, all the way down to schools and universities and landowners and mining companies and nonprofits and interns and AmeriCorps. This list goes on and on and on and on and on. And we thank all of these people for making this restoration such a successful project. And with that, I think I actually kept it to my half hour. I don't know if we're doing time for questions now or at the end, but my contact info is also there. You're welcome to reach out to me at any time. So thanks again for having me.
Thank you, Amy. We will answer all of the questions at the end of the webinar. But obviously, if you have anything that comes up in between now and then, please feel free to put it in the chat or in the Q&A box, and one of us will respond to you shortly. So with that,
Perfect.
Amy, thank you. And then Dr. Yang, you are up. We can see the slide, and feel free if you don't want to have your video on, you don't have to. I think it's kind of lagging over here on our end. If that helps
Oh,
you with
okay.
anything, you're totally fine. So thank you.
I can turn it off. Yeah, I do see that kind of. But can you hear me okay? If
Yep,
that's
everything looks good. Everything sounds great.
okay. Thank you so much for confirming.
Thank you.
Well, hello everyone. It's great to be here, and thank you so much for inviting me. So I'm from the University of Utah, and I've been working on a lot on the critical material extraction from acid mine drainage and mine waste before. And this is actually a project that I started in 2021. And as an independent researcher, this is my very first project. At that time, we were dealing with a lot of acid mine drainage, critical material extraction from the acid mine drainage. And then at the same time, I was thinking, okay, what if we just prevent it from happening? So I'm kind of working on both ways related to AMD. Um, so so first, I would like to express my gratitude to the sponsor of this study. It's actually a 2-year project funded by the Department of Interior through the OSM MDTI initiative, and some team members. And actually, this work was started all the way when I was still in the University of Kentucky. And then in between, I got a tenure track position here at the U, so I kind of take the project with me here. So there was a blend of team members that actually has been working on this. So I think you're all familiar with the acid mine drainage formation. If not, it's actually caused by the pyrite material or some other sulfide mineral oxidation through the very weathering effect. With interacting with air and water, the iron will be released and then generate the sulfuric acid. And then the ferrous ion, which is the Fe2 plus, will be further oxidizing into Fe3 plus, and then the Fe3 plus is reacting with the pyrite again and generating more acid in this case. So there's also a lot of microbial activities in play during this process. This is actually a picture I took from a coal mine. But they were treating this acid mine drainage in the downstream. So no worries on that side. So some treatment method direct neutralization or wetland to seal up the oxygen, or there's some other innovative methods for membranes or biological processes. or in most of them in testing at larger scale pilot or even commercialized scale. So what we're introducing today is actually a little different. So there are some examples of the acid mine drainage that we've been dealing with um, uh, usually in the pH of 2 to 3 range with some rare earth element and iron and aluminum. Some other, this is actually a rock mine drainage sample from Utah and with elevated amount of iron and aluminum in different pH conditions. So in this project, what we were dealing with, we're originally thinking about is, okay, so if we can prevent the acid mine drainage formation by inhibiting the pyrite oxidation, then it would actually prevent it at the source. So some organic acid had been tested for the capability of preventing this pyrite oxidation through electrochemical reaction. So basically, on the cathode, it's providing some electrons, and then on the anode side, this complex the complexation occur. This humic acid or organic compound could bind with complex with the iron and ferrous ions, and then further prevent the oxidation of ferrous to ferric. And this is kind of serving as it's a buffer. So at the initial stage, there are gonna have to be some oxidation where the ferrous ion is released, and then the organic compound can be binding with it and then form this resistor in between of the further in between of the environment and the pyrite surface to prevent the further corrosion. So, and this is some example of the humic acid compound. So it's basically it's a large molecule with a lot of functional groups on the outside. So this got me thinking, like what would be more applicable in the real situation, right? If we actually apply something non-chemical, then one of the source that actually rich in humic acid is the food waste compost. And as we know, that food waste is actually a larger contributor to the landfill, and also it's resulting in a lot of methane emission. And also we have a lot of food waste in the country. And then what these food waste can right now is mostly going to the landfill, which could cause some further environmental problem with the odor and some methane emission. But if we could actually compost it, right now not a lot of food has been composted. But if we could compost it, we could convert it into some soil material, and then this could apply on the mine tailings or applied during the mine waste management. And maybe I can turn the laser on. So this compost material should be rich of the humic substance, including humic acid or some smaller molecules that has a similar functional group as the fulvic acid. So for this project, we actually collected some food waste compost sample from program at the University of Kentucky at the beginning. It's a program that's run by the recycling division. They collect the dining hall waste and then haul it into a certain site to compost with a lot of windrow equipment, and then convert them into putting together some wood chips and leaves to convert it into compost material. So we collect the compost back first, and then following a certain procedure, we extracted the humic acid compound from the food waste compost, and we were able to determine the amount is about 5 to 7% by weight. And then the FTIR was actually showing there were a lot of organic components and some phenol groups and polysaccharides groups that exist in this compost material. And we did compare it with the humic acid bought on the lab grade humic acid bought on the market, and we see some matching peaks that's actually showing the content of the composition matching some of the humic compound material. So we can also see from the SEM image there are some lignin and cellulose material. So for the crystal, the mineral compound, the XRD was performed, and we do see there are some quartz, some calcite, and sylvite, which is the potassium salt material in the compost material. So at the beginning, we were trying to figure out how could this compound, compost help prevent pyrite oxidation. So to make that happen, so in a way, sometimes the pyrite oxidation is also not that easy to happen. So we kind of, to simulate that in the lab, we kind of have to provide it a very oxidative environment. So we developed this oxidative leaching process of the pure pyrite bought from the store, and then using some hydrogen peroxide to stabilize the pH. Some sodium acetate was used as a pH buffer, and the test has been run on an orbital shaker for about 192 hours. So for basically almost 8 to 9 days. And so we certainly want to eliminate the impact. We also want to examine the impact of the pH. So we kind of dial the pH at 2, 4, and 6. And usually the pyrite oxidation occur at lower pH, and then the pH will keep going down. So if we look at these different tests, so the dotted line is actually the system without the compost addition, so pyrite by itself. And if we started with pH 2, we see the pH kind of decreased slightly, and but then with the pyrite addition, the pH has a little increase, but that's also because of the calcite materials provided certain alkalinity. And if we look at the EH though, the system without the compost is at pH 2, having some higher EH value so this actually represents the oxidation potential in the solution. And then with the increase of the pH, the EH value decreases, but with compost, the EH value is decreased further and controlled to be usually below 300 at pH 4. So that's actually showing some prevention of the ferric ion formation. And we also did this test with the fine coal refuse, sample collected from coal preparation plants that contains pyrite, and we see the similar trend. So, but if we look at the iron and sulfur release, so sometimes pH can only reflect certain acid generation, but the iron and sulfur release would actually directly indicate the pyrite oxidation. And in this case we can see that the system without the compost at pH 2 and 6, we both see some iron release. So iron has been actively leached into solution, but in the terms of compost or pH 6, at pH 6, most likely because of the precipitation, but with compost, we see some prevention of the iron release. And similar to sulfur, we see some reduced sulfur release from the system. So the question is also whether this is compost introduced complexation, or is it pH introduced precipitation? So we did some further test on this. And from the pyrite oxidation side, we did some XPS analysis on the surface, trying to trace what is actually happening on the surface of the pyrite. And if we look at these, I selected some of the graph. We look at the iron, sulfur, and the phosphorus, which is the third one. And in the bottom is the raw pyrite material. So the raw pyrites, to begin with, we see a lot of the major peaks are the iron sulfide peak, which matches the composition of pyrite. And then the sulfur also is showing the major peaks being the sulfide and some sulfate. And then in the pyrite, there was almost none phosphorus. But after the pyrites being treated in the compost solution at pH 2, we see some deduction of the pyrite peak. And then similarly, we observe this phosphate peak formed on the surface. So there are some coating formed that contains this phosphate compound. And similarly, at pH 6, the pyrite was further coated, and we see less signal of the iron sulfide and more signal of these phosphate compound. And these are obviously from the compost material. Compost extract is basically water extract from the compost soil. And then later on, we actually brought it into the SEM under the electron microscope, and we did observe a coating layer formed on the surface of the pyrite. So we do see that the organic compound is covering these pyrite surfaces, and then that's comprised of the organic species and some inorganic species like the phosphate. So then the next question is, okay, what does the compost play a role in the heavy metals? Because we do see the iron reduction, whether it is because of the precipitation or adsorption or some complexation processes. So we did some tests with using different dosage of the compost and resulting in the pH rise. And in this case, for example, for the iron removal, usually if we do the precipitation by using alkaline material, we can raise the pH to about 3.5, then all of the ferric will be removed. But if we actually use compost at different dosage, we can achieve that similar removal effect as well. So for iron removal, the major mechanism is by precipitation. But if we're actually looking at copper and some other heavy metal removal, we see by elevating the pH using calcite or some other alkaline material, the copper precipitates at about pH 5 to 6. But if we actually add compost material, although it's elevating the pH, the copper removal shifted to a much lower pH region. So similarly, we see this trend for nickel and lead and zinc removal. They all shifted to the left. So the compost material is actually enabled the metal removal through complexation at a pH even below their precipitation points. So I also did test on some effect of the ferric ion and sulfate effect on the heavy metal removal, because in some cases the ferric ion will precipitate and form material like schromanite or jarosite, which is iron hydroxysulfate, which also has large surface area that could absorb heavy metals like the copper and nickel and cause some co-precipitation. So we kind of generated some solution to test the iron and sulfur effect separately. So if we actually started with a solution with both iron and sulfur, and we can see these element removal with different dosage of compost, following the trend we're seeing before. But if the solution has no sulfate, we observe that at lower dosage of compost, the metal removal was actually lower. So this is possibly caused by the iron precipitation and the so this is actually caused by the less iron precipitate. So the iron is as the ion is competing with the other heavy metals absorbed on the compost material. So on the left, bottom left side, if we actually have no iron, but only sulfur, we see these iron removal resumed, especially at the low compost dosage. And this is likely because of the resumed absorption capability. And if the solution has no iron and sulfur, this removal efficiency is further elevated. So this kind of shows that the iron is competing with the heavy metals, and at the same time, sulfur is providing a complexation drag force to dragging back the heavy metals in the solution by providing this complexation effect. So some more on the heavy metal absorption side. So another question is, okay, if we're saying the iron is competing with the heavy metals, how do we know that it is not just caused by the pH shift? So we conducted a test with different dosage, a different concentration of ferric ion in solution, and then with the same dosage of the compost. So the A plot on the left. And then the pH was slowly raised by the compost from 3 to 4. And we see the removal of the heavy metals like copper, nickel, and zinc material. So for lead material, we controlled the ppm to be very low, but still the lead sulfate has low solubility, so it's having some high removal efficiency. But this is with the compost material. So if we don't have the compost in the system and same system with same solution with different amount of the ferric ion, and we see that with more iron concentration, the removal of heavy metals tend to be increased. So this copper is slightly at the higher iron dosage, is slightly higher removal and similar to zinc, and then also similar to lead, and providing the pH was controlled under the same level for both of the system. So this actually reflects that there are some metal removal caused by co-precipitation with the iron precipitation. But the difference between the two charts is the absorption and the complexation capability of the compost material. So later on, we actually did some long-term leaching process, and I think I'm going to show some major results since I'm probably running out of time a little bit. So what we did was to prove that the compost can help with the acid mine drainage prevention for long term. And in this case, it's a lab test. So long term, we're talking about 70 weeks. So we had two systems built. ABC columns are actually using the coal refuse with about 9% iron content, so reflecting some composition of the pyrite. And then DEF columns are actually dosed in with additional pyrite, trying to see what is the limitation of the compost. So for the three columns in each system, we start with baseline with just coal refuse, and then coal refuse with compost mix. And then the third one, what we're trying to mimic is if we don't have the compost material mixed in with the refuse, but instead just put it on the top of the pile, and then the drained water will be delivering the compost extract and humic acid compound or organic acid into the pile. What would that effect be? So calcite was added in column C because the compost itself contains some calcite. So proportionally, we added the equivalent amount of calcite in this case. And then the leaching test was conducted by flushing water through every week, and then with air flow rate for 2 days, and then heating lamp every week for certain times to mimic the weathering effect. So what we see over the 70 weeks of the leaching is we see that in the column A, which is the baseline column, after about 25 weeks, the pH start to drop to 2.5 and below, and then stabilize at pH 2.2 range. And but for the other two columns, the pH has been sustained at neutral and or above. And then from the EH side, we see there are some fluctuations. So it is actually reflecting the ratio of the ferric to ferrous ion. So although we don't see a lot of pH drop in column B and C, we do see some fluctuation of EH. So that's actually showing that there is some oxidation of pyrite occurred, but is further seized during this process. And this is for the high pyritic column, and we see the acid generation was a little bit earlier than the lower pyritic column. And in this case, we do see that for the column with compost, it started to dropping at the end after about 50 weeks. So there is a limitation of how the compost can bear. And so here we can see the iron release from all the systems, and of course only the one that's actually being acid being generated has iron release. But in terms of sulfur, we actually see that all systems released some sulfur. And toxic metal, in this case, we have included arsenic, cadmium, cobalt, chromium, and some other heavy metals in this case, combine them all, and we see the release of these toxic metals in the compost treated system is less than 0.2 milligram per gram, which is actually meeting the effluent limit. So another interesting thing we see is there are some coated material formed on the surface of pyrite. So this is actually the column D without compost, and then after the leaching process, for a year, we see there are some changes on the surface. But if we actually look at the compost, look at the material from the column with compost, we see these agglomerates formed on the surface of pyrite. So we actually took these material and did analysis under the SEM and TEM, and then we see that this is actually a coating layer on the surface of pyrite that contains some clay materials like muscovite and biotite. And this is likely because of the agglomeration of the organic, it's an organic mineral interaction agglomerated on the pyrite surface, which further prevented the acid mine drainage formation. And we also, so the interesting thing is we don't see any trace of the organic material anymore. So we send the sample to the soil lab for dissolved organic carbon analysis of all the water collected over a year of time. And we do see that the organic material is actually slowly releasing through this column leach process, and indicating the organic matter degradation during the process. So the organic material is playing a role to initiate this organo-mineral interactions and form this coating layer, and then slowly decompose and leaving the pyrite surface. But it's still leaving a layer of the compound on the surface for further prevention of the acid mine drainage formation. So with that, here's my conclusion. It does have the compost material is effective in preventing the acid mine drainage, and we did a 70-week leaching test and kind of showed the mechanism of the prevention. And this potentially be a very good method if we cover the waste material with a layer of the compost. And of course, this kind of have to be associated with how high the pyrite material content is. And slowly, this could introduce a secondary mineral formation that further prevent the acid mine drainage formation by providing a passive layer. So thank you for your attention, and I think I'm right on time as well.
You are right on time. Thank you so much, Dr. Yang, for that wonderful presentation, and the depth of that is amazing. And at least for myself, being from Northwest Ohio, that's not typically something I think of in our area. You know, we do have those other water quality concerns, so it is wonderful to see some research on the up and coming possible
Thank you.
projects and stuff for that.
Appreciate it. Yeah.
Yeah. And with that, Jeff, you are up.
All right. Thank you. So, well, Dr. Yang, at least one person enjoyed some mineralogy. It's been a long time since I've been in the crystallography lab, but I can at least appreciate it. All right. Is it ready to go?
I can see. Yep, looks good.
All right. Excellent. And you said it's probably best if I turn my video off.
Yeah, you can turn yours off to it. That's perfectly fine.
All right. Will do.
Thank
All
you.
right. Well, thank you for the invitation to visit with you guys about some ongoing issues. This one is not exactly water quality, but it's certainly tangential to water quality, and this is some work that is still ongoing, although it's tailed off considerably up as a result of the East Palestine train derailment. Um, and so I say we as Ohio State Extension, and particularly Haley and who's one of the co-authors on this, has been instrumental, and she's up in Columbiana and Mahoning County as the educator there. Um, has been instrumental and very involved in this from the from the beginning. And so we were brought in really because of interest and need to evaluate what was going on with agricultural products. And so I'm going to give you a little background about that. But as we're going through this, realize that the tie-in with water quality is actually very close because a primary concern for the wider community around East Palestine, and by the wider community, I include other outside the immediate impact zone of the incident, which includes our neighboring counties across Pennsylvania, where much of the aerial or the um, atmospheric deposition would have occurred because of the prevailing winds. And so, um, because of that, whatever was we were interested in from an agricultural products perspective is also important for understanding water quality and the impact of water quality. And I'll touch base just a little bit on a few water quality items as we go through here on just what happened. And I don't know how many in the group are completely familiar with the site, so we're going to go through it. Hopefully, it's not too much detail, and I'll try to make sure we leave time at the end for questions. So if you want to go back and ask some more detailed questions about that, we'll be glad to help out. And actually, I believe Haley might be on this call, and she'll probably be willing to jump in there and help out as well with any questions we might have. This was really a team effort, not just Haley and I, but also a number of folks here on campus in Columbus who work with us on the analytical side. Some of you may recognize Heather Raymond, who helps head up the water quality team here at Ohio State, as well as Karen Chow, who's a toxicologist from Michigan State, and she was very instrumental in helping us do some interpretation of and just knowing what to look for as we dealt with this. I'm going to go through this because I know you've probably seen a number of these images before. And we have the derailment. There were 150 cars, approximately 50 of them were affected by the derailment. These are just some pictures that were immediately following the incident. This one, and I believe these were immediately following the incident and not because of the vent and burn. So this was from a neighboring farm just outside of East Palestine, and you could see the flames against the skyline there in the evening sky. And so that was the incident itself. Here's just an idea of the manifest, and one of the reasons this isn't to overwhelm you with all the items, and so I did highlight a few of them. One, notice all the ones in blue; those are petroleum products. So there are a number of petroleum products, industrial chemicals, and so when we see all those trains going across our the railroads or the railways across Ohio, realize that they carry a lot of industrial products. And we can see how many of them were included in this manifest. We have some other items. I'm sure that there were a number of folks who were really bummed out about the 9 cars of malt liquor, and I think that that says a lot when you compare it to the number of other types of products that were in the car. So. Um, but the one down here on the bottom that I've highlighted, that was the big one that really caused us a lot of concern as we have had to deal with this event moving forward. Um, as you know, there was a mandatory evacuation area for anywhere from 1 to 2 miles, and so that included about so anywhere from 1,500 to 2,000 people. Then on February 6th, there was a controlled vent and burn. And we now people may question the decision that was made, but the decision that was made was really a decision based by the incident commander, who was a local fire chief, as well as in contact with the governor's office. All right. And they made their decision based on the best data that they had, the best information that they had that was coming from Norfolk Southern and its advisors or its consultants. All right. And so the information that the governor's office had and the incident commander had was that the one of the cars of vinyl chloride was damaged. All right. And there was a concern about temperatures rising in that car. And as a result of that, there was concern about an explosion. Well, there's been past histories where these cars of vinyl chloride have exploded. There was one that happened about 40 years ago down in Louisiana, and when that car exploded, that car was about 600 feet in the air, they estimated. So this explosion, if those cars had exploded, that was going to be a very bad outcome in the community. The other option that they had was to open to basically vent the tanks, which means open the vents and let them drain out. The problem is that vinyl chloride would not remain in the soil. It would immediately flush through the soil to the groundwater supply and basically create a large pool or lens of vinyl chloride in the groundwater underneath the region. And then the issue here is that that was going to be a slow leak into the Ohio River for who knows how long. All right. Because once it's in that groundwater system, it's going to be very hard to control and manage and clean up at that point. So that was another bad option, right? And the third bad option that they had to choose from was to open it up and then have a controlled fire, which is obviously the one that they chose. All right. Now we know that because they chose that option, as a result, there was a release of dioxin and furan compounds, which happens with any time we burn. Anybody, I know growing up as a kid, I grew up on a small farm, and we didn't have a trash service. We took our trash down to the 55-gallon drum and threw it in there and set it on fire. So anytime you go out and you burn a pile of leaves or you burn sticks, you're creating dioxin. If you burn your steak on the grill, you're creating some dioxins. And so that's just a compound that comes from the burning process. But we also knew that these semi-volatile organic compounds would also be released as part of that. The problem is that once they're in the air, they're going to be dispersed. But the concern was there if they're dispersed across the landscape following the burn, that was the least hazardous for the immediate concern. Again, we can look back, hindsight's always 2020, but based on the information that the decision makers had, this was the best of three bad options or maybe the least bad of three bad options. Here's the result the next day after the fire. All right. Now, obviously, EPA was involved with this from the beginning. They were right on site as soon as it happened. And if you'll notice, there's the East Palestine dashboard. So you can actually go look up all of the information. I'm going to go to this in just a second. You can go look up the information that was all the date. Oh, I guess I don't know how to spell data. All the data resides here. So you can go look at that. I put the QR code in there so that you can go review that if you'd like to. So in here, you can go in here and see the data that was collected by EPA. They have ongoing updates from EPA. Here you can look at the air monitoring and sampling data. Here is the soil sampling and sediment sampling data and the water sampling data. So you can see what they did over the past few years at that location. All right. There's also a number of other resources that you can get here. You can see documentation that were created, all of the work plans, the Freedom of Information Acts, everything else, newsletters, and somewhere in here, I know you can find the photos. I don't see it right now, but I know that there's actually a site here where you can go look at the photos associated with it. So just to show you guys that that is out there. From the soil sampling perspective, they collected about 148 locations and nearly 400 or almost 500 samples there. We can see that they followed QA/QC, so that's quality assurance, quality control. So all of these samples were very carefully monitored. And as a matter of fact, there was a recent question about one of the contractors who was involved with the sampling. And there's actually an investigation going on, and their data was actually thrown out because there were some questions about that. So there's a number of people who question sometimes what um, you know, uh, the data and what EPA is doing, but I can assure you that EPA was not working for Norfolk Southern. Let's just put it that way. All right. Here's some of the sampling. So this is kind of it's almost a cone if you want to think of it that way, a cone of interest. And so this was within I think this was the 1 mile radius as I recall, and then a 2 mile radius. And then you can see out here is 2 miles, and this is over into Pennsylvania. You can see this the white line right there. The gray line is the state line. So you can see that there was a lot of sampling around the incident site, and then some as we moved out downwind. All right. There are also some samples back here, and this was primarily upwind or was considered outside the impact zone over here in the kind of the northwest quadrant. And so these were used for background samples. In other words, they were areas that were believed to be outside of the impact zone of the incident, and therefore would give us some background information about what happened and about what the sites may have been like prior to the incident. There was a lot of emphasis on drinking water and drinking water supplies, obviously, because the community and a number of private wells are located very close by. So EPA installed numerous water monitoring wells. There was weekly sampling. All of the samples were split. They were sent to two labs, and the same thing with the soil samples. So this is not relying on just one set of data. All QA/QC procedures were followed. All EPA procedures were followed on sample analysis, etc. So We have fairly good confidence in the data. And just so you know, also, there was an outside team of university personnel and consultants and non-federal agencies who reviewed all of this data that was collected by both those associated with EPA and any contractors associated with Norfolk Southern. So, actually, Haley and I were part of the team that was evaluating that data that was coming in from all of those sources and being able to share with the public the confidence that we had in the data that was collected. Well, for our purposes, what we found is that, and this is in particular, Haley was the front person. There were a number of questions that came as a result of this vent and burn event that from our agricultural producers. And as I mentioned earlier, the tie-in is that the same things that would have been impacting these producers would also be impacting the water supply in the region, at least surface water. So that'd be our rivers, streams, ponds, and lakes. All right. And so one of the questions they had was, it really was about livestock. Is there an issue related to my livestock health? Is my pond going to be a safe drinking source for my livestock? Is the grass that my cattle are eating, or is the hay that I put up, is that going to be safe for animal consumption? How do I prepare for the upcoming season? And these were all questions, quite frankly, that this is not a reflection on Haley's ability. We were not prepared to answer. That's just a reflection on as Ohio State Extension, we realized as a result of this incident that statewide we were not ready to respond to this. Fortunately, because many of the folks in our counties in the eastern tier and the close proximity to to the nuclear plant, I forgot the name of the nuclear plant, but Haley knows it, is that they have biannual training for nuclear disasters. As a result, those folks in those counties, Haley included, were ready to interact with the emergency responders and were right there the day of the incident. So that was really, really important in helping us be able to navigate this. So really when we looked at it, and this is a picture actually of the room where we held a producer roundtable. And I think if we boil it all down, the key question for the producers is that they had, because their customers were asking them, are my agricultural products going to be safe for consumption? And there was some concern about dairy, which goes right into our school systems. There was concern about folks who were growing winter vegetables and spring vegetables for farmers markets that were going to be marketed in the Cleveland, Youngstown, and Akron area. And so there was a lot of questions about this. And so there were a number of folks involved, and you can see that it was highly, highly attended. And this picture doesn't even capture the number of local and national media that were present as well. So there was a lot of interest in this, and so we realized that we were going to have to deal with this. Again, this what we found as a result of this incident, and particular this vent and burn, is that there were some questions that we didn't know how to answer that these producers were asking us, that the farmers were asking us. And there's a lot of information about what we do with air samples because EPA has a lot of guidelines on how you treat air samples. They have a lot of guidelines on soil samples. They have tons of work and guidelines and methods about how you treat and sample for water, but nobody had put together, how do we analyze environmental plant tissue samples for consumption by human or animals? And so we realized that nobody knew how to do this. And so we actually had to sit down and figure out, how are we going to do this? What do we need to analyze for? What materials should be analyzed? Um, what methods are going to be what methods should be used for both the plant and the animal products? If if they are present, what is the toxicity and risk levels? And we did all of this under the umbrella that we knew whatever we came up with would could very well likely end up in litigation. What we realized was that of primary concern was going to be the plant tissue samples because that's an ingestion pathway that was going to be most prevalent for cattle, chickens, or any other livestock that may be consuming these plant products. And so we knew that we were going to have to analyze for this. This was high priority. You can see when we went out to do the initial sampling, the governor and the Brian from who was the head of the Department of Ag, uh, Ohio Department of Ag showed up, and they were very, very involved and wanted to know what was happening. Um, Unfortunately, excuse me, I've got a cough, so let me try to mute myself, but I may not be able to do it. Sorry about that, folks. Um, they were very involved. Unfortunately, the dean's office, and the lawyers in the dean's office had watched too many episodes of CSI, and they thought that you go out and collect the samples, and the analysis done is able to be conducted and results back during the commercial break. It doesn't work quite that way. Um, but there was a lot of work. This took a lot of coordination. It was Ohio Department of Ag, Ohio State Extension, Farm Science, USDA Farm Services, um, and then Ohio State Research and Extension staff. And again, we did not have a protocol for how to do this. The other big part about it was the engagement with producers. The growers in the area were very, very interested. They needed answers, and so they were very involved. Of primary concern were the dioxins and furans because of concerns about not only animal health but long-term human health. The challenge with the dioxins and the furans is that the testing analysis for these is very expensive. We're talking about you know, maybe hundreds of dollars per sample, depending on the extent of the sampling. And so this is something that you've got to have pretty deep pockets to do more than to even do one sample. You could be talking upwards of $500 to $600 for one sample. So what we knew was that it was a lot easier, a lot less expensive. I won't say easier, a lot less expensive to be a sample for the semi-volatile organic compounds because we knew if we could find them, there would then or then there may be dioxins and we could go back and sample for those dioxins. But if we didn't find the semi-volatiles, then we probably didn't need to worry about the dioxins and furans. The other thing that gave us some confidence about the dioxins and furans is that EPA had already done quite a bit of sampling for dioxins and furans outside of the impact, away from the impact zone. And they were essentially background levels for almost all of the places. The locations that EPA did have high readings for dioxin and furans were places that you might expect that they were close to some industrial site or a roadside where who knows, anything could have been dumped as somebody was driving down the road. So um, we were fairly confident in that. What we figured out is that EPA has some standard tissue sampling related to pesticide residues. And this is very commonly used by Ohio Department of Agriculture, especially if there's any question if a farmer or producer has concerns that maybe their crop was injured by some spray event for a neighbor or if it's going to enter the food supply. And so Ohio Department of Agriculture has a team, and we see that team down here in these bottom two photographs, who are actually went out and did the sampling. And so they followed QA, QC, and chain of custody procedures as prescribed by EPA. All right. And here was the key, and I highlighted this. We did not know how to get, we didn't have, there is not an approved method of how to get the compounds from the tissue into a method that we could analyze, all right, into a form that we could analyze. We have an analysis method here for EPA, but it was this extraction method that was our problem. And fortunately, we happen to have a colleague who works for Campbell Soup, and Campbell Soup routinely tests every batch of plant tissue that comes in. If they're making tomato soup, they analyze every batch of tomatoes that come in to make sure there's no chemical residues, pesticides on those tomatoes because they're going in the food stream. And so they said this might be a way to do it. So we were very fortunate about that. So that was the key. Here's our sampling. We went out and collected our samples. These ones out here were considered our background samples. And then inside the yellow, that's where we collected our tissue samples that were considered to be from the impact area. And so now these are aggregated because that was one of, we ensured the privacy of the owners, the landowners, so they were the only ones who knew their results. And this is the first time, I mean, I've never been so glad to see non-detects or below detection limits for any project I ever worked on before. So it was very helpful to be able to go and talk to the growers. You could see the relief on their face when we said, hey, look, we sampled your location. We're not finding anything of concern. Now, I did highlight this one, the benzo B fluorethylene. And that was one location that we had amounts above highly above detection levels. But it just so happens that that was actually in our background zone. And this is a compound that could be found in like hydraulic fluid or something like that. So who knows? It was out in I think it was in a pasture if I remember. So who knows? Maybe the tractor broke down or the baler broke down and somebody was sitting there. And we just happened to sample from the one site where there was hydraulic fluid on the ground. Um, Here are some area, or this is where if you want to go see that information, here's a QR code, and you can see the information that we shared with the growers. It won't have each individual site, but it will give you an overview of the entire sampling project and what we found. And it'll have the whole table. I just cut it down to that last table. I just cut it down so that you could see the range of compounds that we found. Okay. Um, so some takeaways. One, we found out that there were some gaps in understanding how to analyze agricultural materials. This is something we're probably going to need to work with either within Ohio, but I think we'll be able to move this nationwide moving forward. About how we deal with this. We're going to have to bring in some folks like Dr. Chow to work on toxicology issues because it's not about just the compound being there. It's about how much is being ingested in either over a chronic period, which is long term, or an acute, which is a one event. And so we need to have some idea and some information about that. This is a picture of where the tank farm was. So you can see that the site is back up. It's really in good shape right now. There's monitoring wells everywhere. All of the soil was dug up. They went back and resampled, double checked everything, brought in new soil. The soil that was extracted was, I think most of it was incinerated. Um, Sulphur Run, which is one of the tributaries that was most degraded by the incident, is opened up and free flowing again. We have sentinel wells in place for constant monitoring. This is a recent study by Dr. Laird. He's now at Kent State. He was down at Louisiana State when he actually was engaging with Haley and I on this project. And he did some dioxin and furan soil sampling. And this is a paper he just published late last year. And his data lined up pretty closely with what Norfolk Southern sampling and EPA sampling regarding the site is that a lot of the samples, like half the samples, were below the residential screening level for cancer. The residential screening level is, if they go out and they evaluate a site, they want to know what is the amount that if there is, and this, so think about it this way, this, if there's possible a health risk, we need to go back and do some more detailed sampling, okay? So this is like actually a conservative number, this of 5 picograms per gram of soil. So what they most, half of the samples were below that, so they're basically background. Really, anything below 4 picograms is considered background. There were a number of samples. There were 11 samples that were above the residential screening level for cancer, and there were 2 samples that were above the non-cancer residential screening level. And so, in essence, these samples were all in close to the site. And so, just like EPA and Norfolk Southern found, is that the locations close to the site were most impacted. Um, Haley has conveyed to me that folks still come in and request soil. They're concerned that their soil might be contaminated. They don't, they, Many folks are under the uh, misunderstanding that this is only going to be $20, like they were going to get a soil sample done for their soil fertility, but this is more going to be like $500-600 per soil sample. And so usually then they say, okay, well, what does EPA, what does Ohio State say about the data? Growers still ask as we move into the growing season, are my products going to be safe? And one of the things that is definitely a benefit is that the National Institutes of Health has funded some long-term health studies. And so they're encouraging, strongly encouraging. I think we would say are strongly encouraging folks to participate because this can help provide some baseline that if issues arise with health concerns, that we have the data to be able to link it back to this event. Um, One of the things that we realized that these events occur way more frequently than we realized. And one of the big things that Haley and I have continued to work on is we're working with our administration statewide in Extension and the College of Food, Agriculture, and Environmental Sciences is to make sure that we are ready to respond to these events because we don't know when they're going to occur. And honestly, with the reshoring, we hear so much emphasis on reshoring of our manufacturing. If that's the case, we have to be even more prepared because we could expect more manufacturing locations and sites across the U.S. And so all of our folks in our Ohio State Extension and all of our extension offices are going to need to be prepared to support the people of their county when these things occur. So with that, I'm going to stop and I'll join in on any questions that there might be. Here's my contact information if you have some questions, and you can use that QR code to also get to my website where you can get to my information as well. With that, I know I might be just a tad over time.
That is okay. Excuse me. Thank you, Jeff, for that wonderful presentation. And I am going to share my screen. We can take any questions at this point in time. I know Dr. Yang did have to jump off as she had to go teach a class. So if anyone has any questions for her, let us know and I will get those to her and we can go that route for her. I do see one question in the chat here, but before that, this QR code that you see on your screen is for feedback. It's a feedback survey for the Water Quality Wednesdays series. So you can either scan that QR code or the link will be dropped into the chat. And we will get your credit options for that CLM, the poll. We will get that here in just a second after we're done with the questions. And then I will also have the CCA credit slide after this. So that first question that I see, if someone, Amy, this is for you, if someone would want to visit Raccoon Creek and maybe kayak or camp to learn more about the remediation projects, that are on that area, can you suggest a specific place to go?
I did message her back, but I should have messaged it to everybody. Yeah, so the livery that I was talking about that does canoe and kayak trips on Raccoon is Raccoon Creek Outfitters. They're private. I mean, they're in no way associated with Ohio University or Raccoon Creek Partnership. They are great and wonderful supporters. We often hold our summer camp and events out there because they are right on the creek. But Raccoon Creek Outfitters offers a couple different canoe, kayak, float options in the headwaters of Raccoon Creek. Also, in the headwaters of Raccoon Creek, they do have camping at the Outfitters too. I forgot to say that earlier. Um, and also, Lake Hope State Park and Zaleski State Forest are in the headwaters, and there's camping opportunities there. A lot of public property. Lots of recreational opportunities. There's also backpack trails through Zaleski. Down on the lower sections of Raccoon Creek, this has always been a question. There's not really any streamside camping and very little public property on Raccoon Creek in the lower sections because it's mostly privately owned. There is a county park down in Gallia County. O.O. McIntyre County Park is down in Gallia County, so that's closer to the mouth. So yeah, those are some options of places that you could put in and float. Obviously, the waters are public, navigable waters, but do respect private property. If you have to portage, that's one thing, but you can't just get out and camp on someone's property without permission. So, yeah.
Appreciate you answering that. I am going to launch the poll right now for the CLM credits. So if you do need those, please select yes or no and enter your name. We do need both parts in order for you to get those credits. Jeff, maybe a question for you or Haley, whoever. You mentioned all of the questions with this incident that arose in the agricultural side. What was kind of maybe the I don't want to say weirdest or wildest question, but what was kind of one of those off the wall questions that really made you guys think within that?
Oh gosh. Well, Haley could keep us another 45 minutes with all of her crazy stories. I'll share one. Um, there was a gentleman who came in and wanted to know about his peaches. All right. And so he came in, he said, "Are my peaches safe to eat?" And so this was in the fall after the incident had happened in February, okay? Well, first, that year's crop of peaches hadn't bloomed yet, if I remember. And and then so at the end of the conversation, then he told her, "Oh, well, I already ate them." So it's like, well, why did you ask the question? You're not dead yet. So Um, yeah, there were a lot of questions and um, a lot of really unique things. Honestly, I think one of the challenges about this location or about this event, and this is from a serious perspective. One of the challenges about this event is the number of people who were using this event to push their own agenda. They had some issues, an agenda that they wanted to push, and they saw this as a way to get a lot of visibility. And that for me was probably the biggest issue about this event was that there were so many people who were trying to gain visibility, and they were making some claims that were maybe there might have been they were only partially accurate, and they were making claims that they couldn't back up and there were some folks who came in and said, well, we do testing, but then they would never allow their test results to be evaluated, reviewed, and they wouldn't allow, um, you know, um, I guess just double checking of their results. And so those were some issues that we learned. I'll just give Haley some kudos because those of you who are also in extension. This is something that I would encourage you is maybe get some experience in, I don't know if crisis management, but crisis communications. Haley's got has some communications background, and that served Ohio State very well, and it served Extension very well because she was able to kind of evaluate how some folks were approaching the event and the outcome. So that was there's a number of those. I don't know if Haley might not want to share them. She might get in trouble if she shares her stories.
Looks like she commented here. So many questions. One of the most unnerving aspects was trying to anticipate intent and sincerity. The aftermath of a crisis brings multiple facets. Some are darker than we realize at first. Yeah, and unfortunately, especially within extension, specifically, and in those county offices, you never know who's going to walk through those doors, and what their intent is behind it. So I do thank all of you guys for being on and for speaking today.